My name is Alex Galt. I'm a teacher at Edina High School, and this lesson is about using domain and range with real-world problems. So my goal for you by the end of today is to be able to describe a function's domain, range, and a little bit end behavior, but really it's mostly about domain and range today. Okay, the first problem with a real-world problem here is about a candle. The candle is 6 inches high and it's burning down at a rate of 1 inch every 2 hours for 5 hours. So the first thing I'm going to do is fill in some data for the table. If the candle's been burning for 0 hours, we know that it's 6 inches high. And we know that every 2 hours it burns down another inch. So it will be 5 inches tall after 2 hours, and it will be 4 inches tall after 4 hours. If I wanted to know how tall the candle is after 1 hour, it's going to be halfway in between these two values, so it would be 5.5. After 3 hours, it would be 4.5 inches tall, and after 5 hours, it would be 3.5 inches tall. For this problem, because they gave me kind of a restriction in the domain in the wording of the problem, our domain is going to be different from the other problems. It's not going to be negative infinity to infinity. We have to pay attention to what makes sense in the real world. They told me that the candle burns for 5 hours. So the domain is going to be from 0 to 5. It doesn't make sense for the candle to burn negative hours, and they told me that the candle stops burning after 5 hours. The range, because I now have all of those 5 hours in this table, the range is going to be the lowest value in my table. Remember, we always start with the small number for range, so we're going to start with a 3.5, to the largest number in my table. So it's going to be from 3.5 to 6. And then we want to write an equation for the function h of t. In order to be able to write that function, it's kind of helpful to look at the data in a graph. So I noticed that 0, 6 is on the graph, and I noticed that 2, 5 is on the graph, and 4, 4 is on the graph, and 5, 3.5, and these values all lie in a straight line. We know a lot about straight lines from algebra class, Algebra 1, and it's helpful if you want to write an equation for a straight line to remember y equals mx plus b. B is going to be the y-intercept. That's also the initial height of the candle, so the y-intercept is at 6, and then slope is going to be, if I look at the slope, this thing has a rise of, well, 1 or -1, and a run of 2, so I'm going to say -1 for a rise. This is a downhill line, so I know that my slope is going to be -1/2. Okay. I can also see the slope kind of worded in the problem. I can see that the candle's burning 1 inch every 2 hours. Since the candle is burning, it's getting smaller, so it makes sense that the slope is negative. And so our equation for the line, if I use t's instead of x's, is going to be h of t equals -1/2 times t plus 6. The slope and the y-intercept are in that equation. Okay, this next example is about the fuel efficiency for a car. It's 35.6 miles per gallon. The gas tank for this car holds 16 gallons. So if I'm willing to use 0 gallons of gas, then I'm going to not be able to go any distance. But if I'm willing to use 2 gallons of gas, since my number of gallons is 35.6, I'm going to take 35.6 times 2. And so if I multiply that out, that's going to be 71.2 gallons of gas. Miles traveled, sorry. If I use 4 gallons of gas, I can go 142.4 miles. If I use 6 gallons of gas, I can go 213.6. And if I use 8 gallons of gas, I can go 284.8 miles. I'm just multiplying it out, and I've already multiplied it out, but you can use your calculator or you can multiply by hand as you figure those numbers out. Keep in mind, this is not a full table, because this only goes up to 8 gallons, but they told me that my gas tank can hold 16 gallons. You might want to add a row for 16 gallons. If you use all 16 gallons of gas in the gas tank, then you're going to go 569.6 miles. That's as far as you can travel on a tank of gas for this car. So domain is going to be from 0 to 16, because that would be a full tank of gas. Oops, 16. The range is going to be from 0 to 569.6 miles. And then to write the equation, it's sometimes helpful to see a picture so we can plot some points. So we have 0, 0, we have 2, 71.2, we have 4, 142.4, and it looks like it's going to be a straight line. Okay, the highest point on my line is going to be a little bit above where my grid lines go at 16, 569.6. Okay, so how could I figure out the slope of this line? Well, the slope of the line is going to be the number of miles I can travel for each gallon of gas that I use. So it's going to be miles per gallon. Well, I know miles per gallon. Miles per gallon is going to be 35.6. That's the slope of my line. The y-intercept of my line is going to be 0. So if I want to write the equation for that line, it's going to be d of g. That's the wording they gave me, so that tells me that the x-coordinate is going to be g. So it's going to be 35.6, which is the slope, times g. And that makes sense because that's how we found these values. We multiplied 35.6 times 2 gallons. Okay, so that's the equation for that function. Okay, in this problem, the walker is starting 4 miles away from home. She's walking at a steady pace of 3 miles per hour towards her home for 45 minutes. That means that she's getting closer to home, but she starts her journey 4 miles away from home. She's only walking for 45 minutes, but she's going 3 miles an hour, which means that in half an hour, she's gone 1.5 miles. She's walking towards home, so she was 4 miles away, so she'll be 4 miles minus 1.5 miles away at half an hour, so she'll be 2.5 miles away from home at that point. And then if she's gone a quarter of an hour, she will have gone half of 1.5 miles, so she'll have gone 0.75 miles, and so she will be 4 miles away from home minus the 0.75 miles that she's walked, so she'll be at 3.25 miles. At the end of her journey, when she reaches 45 minutes, she will have walked another 0.75 miles, so she'll be at 4 minus 2.25 miles, and she'll be at 1.7 miles away from home. So her domain is going to be the amount of time that she walked. She walked from 0 hours until 0.75 hours. Her range, remember, is going to be the smallest y value, or distance from home, so 1.75, 4. And it includes both those values because she really was 4 miles away from home at one point. And then for the graph of the equation, I think it's helpful to see a line. So 0, 4, 0.25, 3.25, so something like there, and 2.5, 2.5, so something like there, and 0.75, 1.75, so something like there. So here's her line, and it stops here. But keep in mind that if it continued to 1, her slope would be 3 miles per hour. So remember, the slope of this line is 3 over 1. The units here are weird. So the equation for her line, the slope is going to be 3, and the y-intercept is going to be 4. So her equation for her line is going to be 3t plus 4. So this chapter got at reviewing domain and range in a real-world situation, but then also writing linear equations from a set of data.